questions 21 through 25 on the 2008 Grade 10 AMC 10B. 10 chairs are evenly spaced around a round table and numbered clockwise from 1 through 10. 5 married couples are to sit in the chairs with men and women alternating, and no one is to sit either next to or directly across from his or her spouse. How many seating arrangements are possible? First, let's draw a couple of diagrams and let's work with the information they give us in the question stem. So these are the chairs numbered 1 through 10, and they've got a few rules. The rules are as follows. The first thing is that we have to alternate men and women. That's the rule right here. Men and women alternating. All right, so I guess we can start with women, ladies first, right? So women, men, and so on. And now our task is to figure out how to arrange this. So, first and foremost, how many men and women do we have? We've got 10, right? So we've got M1, W1, so man 1, W1, indicating that they are husband and wife, like that. And then similarly, M2, W2 is the second married couple, and so on. All right, so here we go. Let's start with this. So the very first chair I'm going to designate as W1. All right, it's got to start somewhere, so I might as well start there. Now let's just look at the women first. The remaining 4 women, which are right here, have to be chosen in a certain way. So if I were to draw out their combinations for the remaining 4 women, the first slot, which is here, I've got 4 different choices, correct? Either it's going to be W2, W3, W4, or W5. And then once I select her, for the next slot, which is here, I've got to put any of the remaining 3. So I've got 3 choices. And then once she's placed into a chair, I've got to put a woman there, and I've got 2 choices. And finally, I've got 1 remaining choice for the last seat for a woman, a wife. And that, of course, you multiply them, and that gives me 24. 24 different ways to do that for W1. Okay? But remember, I started at chair number 1. I could have started at any of the 10 chairs. So this 24 can be calculated for any of these 10 chairs. So any of the 10 chairs can calculate this 24 combination. So the total number of seating arrangements for the women is 240. All right? 240 is the total seating arrangements for the women. Now we have to turn our attention to the men. Where are the men going to be placed? Okay. So, first, let's just get an idea with an example. Okay? I think that'll be a little bit easier. So, let's create our first scenario, and that will give us an idea of what it's like. So our first scenario, W1 is going to be in chair 1 as indicated here. And for the other women, I'll just put them in order W2, W3, W4, and W5 like that. Now I've got to figure out the arrangement for the men. Well, first and foremost, where does M1 go? M1 cannot go here or here, right? Because the rule states that a spouse cannot sit beside his spouse. A man cannot sit beside his wife. A wife cannot sit beside her husband. And similarly, you can't sit across. And as you can see, 6 is directly across from 1. So I drew lines in there to make it a little bit more obvious as to what is across. So where can M1 go? Can't go here, can't go here, can't go here. So it can only go either here or here. the M1 can only be placed in either chair number 4 or chair number 8. So let's put him in chair number 4. All right? And then similarly, if you do that for all the other husbands, you'll find there's only one way that this works if you put M1 here. And that is as follows. M5 has to go here. M1 we already placed. M2 has to go here. M3 has to go here. And M4 has to go here. And all the W's we placed. This is the only way that this works. It's the only arrangement possible. If we start off with W1 there, and then of course we placed M1 here. But if we were to place M1 here, you remember that was the only other possibility? We can get one more arrangement as follows. Again, the women I'm going to place in a standard way just to give you one example. So W3, W4, W5 like that. And M1, remember, there was only two places M1 can go. It can go either in 4 or 8. This example talked about it in 4. So in this example over here, we'll talk about it in terms of 8, chair 8. If it goes into chair 8, and we have fixed W1 here and M1 here, there's only one possibility for the arrangements of the other seats. M3 has to go here, M4 has to go here, M5, and M2. Following the rules that no spouse can sit beside her husband or wife, and you can also not sit directly across. So the whole point of doing this is that for any one of these 240 scenarios for the women, there's only two possible arrangements for the men. One like this and one like this. So that means, I think I can squeeze that in here, that for each of those 240 possible arrangements for the women, there's only two possible arrangements for the men. And therefore, in total, there's 480 possible seating arrangements for the men and women together. So number 21, the answer is C. 3 red beads, 2 white beads, and 1 blue bead are placed in a line in random order. What is the probability that no 2 neighboring beads are the same color? We got R, 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 W, W, and B for blue. So, first and foremost, like all probability questions, I got to figure out the denominator, which is the total number. Total number of arrangements for 6 objects, if you were going to put them in order like this, 6 times 5 times 4 times 3 times 2 times 1, right? But this overcounts. Why? Because we have objects of the same color, or essentially the same. So this number, this big number is 720. But I've got to divide 720 by 3 factorial for the fact that there's 3 R's, and 2 factorial for the fact that there's 2 W's. And if I do that, this number brings me down to 720 and divided by 6 times 2, which is 12, and that is equal to 60. So we've taken care of the denominator. Now we turn our attention to the numerator. How do we do the numerator? All right. Well, let's talk about this in the simplest way possible without making this too confusing. We have to place them in order, right? There's 6 in a row. Now, the rule is that no 2 of the same color can be side by side. So let me just first concentrate on the R's. How do I place the R's? Well, they can't be together, so one way is like this, spacing them like that, right? That way they're not side by side. Another way of placing the R's is like this, in a very similar way. They're far apart from each other. There's at least one. Another way would be to place them like this, R, R, and then the last R 2 spaces away. And then similarly, we can also put them like this. This represents all the possible ways that the R's can be placed. As you can see, they're not together, so we have so far satisfied our rule that no two neighboring beads are the same color. Now our task is to place the other ones. We got 2 white and 1 blue. Okay, so let's first just talk about the blue one. These guys are all done. Let's talk about the blue. In the first one, this scenario, how can I place the blue? Well, the blue can go anywhere, right? There's only one blue, so it doesn't matter where it goes. It can go here, or it can go here, or it can go here, right? Now, if the blue goes there, where do I put the white, these 2 W's? Well, the W can go here and here. It still satisfies the rule. The W's are not together. If the blue is placed here, the W goes here, and the W goes here. If the blue is placed here, the W goes here and here. So there you go. R, B, R, W, R, W. That one satisfies my rules, and as do the other 3. So I got 3 possible ways so far. Correct? So far, so good. Now let's look at the next scenario, which is right here. Again, concentrating on the B, which is blue. Where can the blue go? Well, I think the blue can go anywhere. Same kind of story, right? It can go here, it can go here, and it can go here. And if that is the case, if I place my W's, the W can go either here, the W could go here, and similarly here and here, and here and here. All 3 of these satisfy the condition that the beads are placed in such a way that no 2 of the same color are side by side. So I got another 3. All right, doing good. Okay, now let's look at the next one. Where can the blue go this time? Well, the blue can't go here. Why? Because if I put the blue there, the W's would have to go here, and we can't have that because that would be 2 colors that are the same and are side by side. So the W, or the B, I should say, can only go either here or here. And if it does, the white, I can't remember what I'm calling the W's. Am I calling them white or some other color? They're going here and here, or here and here. So either of these would work, and that gives me 2 more. And in a very similar way, by this point, I think you get the hang of this. The blue's got to go here or here, and if it does, the white goes here and here, and if the blue goes there, it goes here and here for the white. And I got another 2. So in a case-by-case way, I've shown that we've got 3, 3, 2, 2, which is a total of 10 ways of doing this. So our numerator is 10. And therefore overall probability in lowest terms is 1 over 6. So the answer to number 22 is C. A rectangular floor measures A feet by B feet, where A and B are positive integers with B greater than A. Remember that. An artist paints a rectangle on the floor with the sides of the rectangle parallel to the sides of the floor. The unpainted part of the floor forms a border of width 1 foot around the painted rectangle and occupies half the area of the entire floor. How many possibilities are there for the ordered pair AB? Let's draw a little diagram here. So we got a rectangle, and then we've got another one somewhere, somehow, like this, approximately. And the criteria is that this smaller rectangle is 1 foot away from the border. So from here to here is 1, from here to here is 1. Similarly, that's 1 and that's 1. And this whole side is B and this whole side is A. So the big one, the area is of course length times width, which is A times B. And the small one, well, we've got to label this. That distance is going to be B minus 2, correct? And this distance here is A minus 2. You have to subtract the 1 from both sides. So the area of the small rectangle is a minus 2 times b minus 2. And they tell me that the relationship is that the small rectangle is half the area of the big one. So there's our mathematical formula. And based on this, we have to figure out how many ordered pairs are we going to get. A couple of ways of doing this. The first way is just expanding it all out and not doing any tricks. So we got ab minus 2a minus 2b plus 4 is equal to ab over 2. Multiply through by 2 and you get 2ab minus 4a minus 4b plus 8 is equal to ab. And if you bring the ab over, you get ab minus 4a minus 4b plus 8 is equal to 0. And what you do is you just kind of plug away on this formula. You can isolate for 1. For example, you can say ab minus 4a is equal to 4b minus 8. Right, I'm just isolating. Factor out the a and you get b minus 4 is equal to 4b minus 8. And then a will be 4b minus 8 over b minus 4. And you can, of course, factor out a 4. And that just becomes b minus 2 over b minus 4 like that. And then you can start plugging away values for b and try to figure out values of a, which would be perfectly reasonable, but it would be kind of time consuming. So what I can show you is I don't know if this is faster. Some of you may not consider this faster, but a little bit of a trick at this point right here. Okay, I'll show you that one. So what you do is you just have the same. You can't change it, of course, but what you can do is you can do a little bit of a trick. You're going to add 8 to both sides like this. If you do add 8 to both sides, it allows you to factor it a little bit better. This whole thing can factor into the following. It'll be a, b, 4 and 4 minus minus like that. And this becomes 8. And in my opinion, this is a little slightly easier to work with than this guy right here. It's up to you. It's up, your comfort level. So what we do is, as always, you make a little table and plug away values for a and b. So I've got a minus 4, I've got b minus 4, and then I got to calculate a and b. Okay? So let's start plugging away, keeping in mind that b is greater than a. That is a very important part of this question. Otherwise, you'll get probably double the number of answers than you should. So keeping this in mind, because a minus 4 times b minus 4 is equal to 8, and we're always talking about integers, and positive integers that is, since they represent lengths, we can easily figure out what these two could be. The only possibilities, considering that b is greater than a, is 8 and 1 and 4 and 2. And that's it. So as you can see, putting it in this form makes it a lot easier than this form, because this form doesn't tell me anything. I got to put in 1, 2, 3 and keep on going. I mean, who knows how long you got to keep on going. But with this one, you just have to test out 2 of them, and that's it. You say, well, what about 2 and 4 and 1 and 8? Why don't you do that? Because b's got to be greater than a. And if b is greater than a, then b minus 4 is greater than a minus 4. So that way, these are not going to be valid. All right, using this, very, very straightforward at this point. If a minus 4 is equal to 1, then a is 5, I think. And then if b minus 4 is equal to 8, then b is 12. Okay, so same thing with the next one. A minus 4 is 2, so a is 6, and b minus 4 is 4, so b is 8. So these are the only 2 ordered pairs that satisfy the conditions, and therefore 2 is the answer. So number 23, the answer is B. Quadrilateral ABCD has AB equal to BC equal to CD. Angle ABC is 70, and angle BCD is 170. What is the degree measure of BAD? First and foremost, let's draw what this could look like. So I've got A to B approximately like that. Then we've got B to C. So something like this, keeping the lengths the same. And then finally C to D, something like that. And then join those guys right there. So let's label this now. We've got A, B, C, D. And the angles, they've given me ABC is 70, so this is 70. And then BCD is 170, so this is 170 right there. And I think that's it. So they want me to figure out BAD. BAD is this guy right here. So I'll call that X. All right, so this is an interesting question in that the standard approach, which is looking at the fact that these are isosceles triangles, right? Because since AB equals BC equals CD, you say, okay, a whole bunch of isosceles triangles. But unfortunately, when you approach it from that angle, it doesn't give you the right answer, even if you try very hard. So you have to use a trick, unfortunately. And the trick is as follows. There's a couple different ways, but I'll show you one of them. And that is you have to draw an equilateral triangle with BC as its base. So something like this. Like that. Okay? So this is equilateral with all three sides the same. And the side up at the top, I'll just call that M. Okay, so let's work with this now, and I'll show you how it's done. Since this is equilateral, all the angles are the same, right? They're 60. So that's 60. And this angle is 60. And this angle is 60. So that means that this angle in here is 10, right? Because this whole thing was 70 from there to there. And therefore, this now is isosceles. This triangle, AMB. And therefore, since this is X, this is also going to be X, this angle. So therefore, 2X plus 10 is 180. Sum of the angles of a triangle are 180. Therefore, 2X is equal to 170, and therefore X is equal to 85. Now, that is not sufficient. You say, well, I got 85. I'm going to circle it and move on. Yeah, but you've also got to prove that M is indeed on this line, right? Because M, how do you know M is on that line? It could be, M could be here. M could have been like this. Just because it's equilateral doesn't prove that M is on AD. The only way to prove that M is on AD is to show that all of these angles add up to 180. So I've already got two of them. I've got the angle X and I've got 60. So I got to figure out that angle there. And that shouldn't be that hard to do. So we turn our attention to this corner here. From here to here is 170, right? They give you that in the question, and we just figured out that's 60. So this angle from here to here is 170, subtract 60, which is 110. And then this angle, this triangle, I should say, is isosceles. So these two are the same, right? So 2y plus 110 is equal to 180. So 2y is equal to 70. Therefore, y is equal to 35. So this is 35. Okay, now I've got to figure out if that indeed does equal 180. All those angles, if they are about a line, must equal 180. So x plus 60 plus y must equal 180. If they do, then we can accept x equals 85 as our answer. Well, 85 plus 60 plus 35 is indeed 180. So that shows that M is indeed on AD, and this is valid in terms of our answer. So number 24, the answer is C. Michael walks at the rate of 5 feet per second on a long straight path. trash pails are located every 200 feet along the path. A garbage truck travels at 10 feet per second in the same direction as Michael and stops for 30 seconds at each pail. As Michael passes a pail, he notices the truck ahead of him just leaving the next pail. How many times will Michael and the truck meet? So we have to first understand this question, and then we have to find out which points do the truck and Michael meet at. All right, so we will figure out Michael. We will figure out the garbage truck, G for garbage, and this is the time. So at the very beginning, time 0, Michael is at 0 in terms of his distance. Okay, so what I'm going to put in this column is the distance for Michael from his starting point. And the same thing for the garbage truck, the distance. Now the garbage truck gets a 200 feet, right? Yeah, 200 feet head start. Because the question tells you that as Michael passes a pail, he notices the truck ahead of him just leaving the next pail. So we're using that as sort of our time 0. So let's work with this. At 50, that's 50 seconds into it, how much distance does Michael cover? Well, he's 5 feet per second, so 250 feet. Now, the garbage truck is a little bit different. It's not continuous. Michael is continuous. He just keeps walking, never stops, apparently. But the garbage truck travels and stops for 30 seconds, all right? So for the first 20 seconds, it travels at a pace or rate, what is it? 10 feet per second. So 20 seconds, 10 feet per second, that's 200. So it was at 200, travels 200, so it's now at 400. Then it stops for 30 seconds and remains there. So that's why for this full 50 seconds, it's still going to be here. So that's a little bit tricky. Not super tricky, but, just have to think about that. All right, let's move forward. Now let's get to the next 50 seconds. Now the clock is running. The cumulative time is 100 seconds. Michael just keeps walking. He covers another 250 feet. Now he's at 500 feet. The garbage truck, same story, travels 200 feet for those first 20 seconds, stops for 30 seconds. So these are the distances now. So this should be 600, sorry. They did indeed travel 200, but we have to put a cumulative distance. All right, so far so good. No tricks. All right, let's go. 150 meters. Again, Michael is pretty straightforward. He's just moving along at the same pace. And so is the garbage truck, by the way. We just have to keep in mind that the garbage truck has to stop for 30 seconds. So this is 800 now. Like that. Okay? Now we get to something that's different, where Michael catches up at 200. He's at 1,000, and now the garbage truck is at 1,000. So he finally catches up to the garbage truck, and that's the first meeting point. All right? And now at this point, the question gets a little bit harder, because we have to now figure out when does this meeting point occur again. And so we can't go in 50-second intervals anymore. We have to kind of break it down a little bit. In the beginning, we're just doing 50-second intervals, and it was pretty straightforward. But now we got to, in a very, in my opinion, painful way, we've got to think, all right, so what happens now? When does the garbage truck leave? When does it stay? And all that stuff, right? Okay, so 240 seconds. 40 seconds later, Michael has traveled 40 times 5, which is 200. So Michael's up to now 1,200. Now, 40 seconds later, keep in mind that the garbage truck has traveled for 20 of those seconds. So 20 times 10 is 200. So again, the garbage truck is at 1,200. Okay? So this is another meeting point at 240. So as you can see, we have to now look at slightly different intervals. We can't go every 50. And that's what makes this question challenging. Now let's just say the 251, which is our standard interval. What happens? Well, Michael's at 1250 now. The garbage truck is still at 1200. Why? Because remember, it stops for 30 seconds. Okay? So far, so good. Now we have to go very slowly in terms of our intervals because they're very close together. And we don't know what's going to happen. They're going to probably meet very quickly. 10 seconds later, Michael's traveled 50 feet, so he's at 1300. But in 10 seconds, the garbage truck travels 100, so it's also at 1300. So at 260, they meet again. All right, so you see what's happening here. We've got to be kind of a little bit more intricate in our time intervals here. So again, let's see. Are we going to meet any other way? Let's try 270 here. I'm just going to go up by tens now. At 270, we got 1350, and we've got 1400. Okay, that wasn't an interval. How about 280? At 280, we've got 1400, and we've got 1400, because remember, the first 20 seconds the garbage truck is moving, so it's moving from 250 to 270, but then from 270 to 300 it stops, right? Those 30 seconds. So there we go. We got another meeting point right here at 280 in terms of our cumulative time. Okay. All right, I'm getting tired of this. Hopefully we can end this sooner or later. 300, we're up to 1500, and then 1400 still, right? Now the garbage truck starts moving, but we got to be careful. Let's try 320. At 320, Michael is up to 1600, and the garbage truck is up to 1600. Great. So we got another meeting point. And then at this point, let's see, 350. Michael is up to 750. The truck is up to 1600. Right? Because the truck is still stationary. It doesn't travel for those 30 seconds. 400, Michael is up to 2000. The truck is 1800. 450. Now what happens, if you notice, Michael is getting farther and farther away. The truck is now not going to catch up to Michael. Okay? So that's it. That's it in terms of meeting points. 2500, 2200. You see how the truck's just getting further and further in terms of a distance. Michael is getting farther away. So that's it. We were done with our meeting points. How many did we get? We got 1, 2, 3, or 5 of them. All right, so that's painful in my opinion. And therefore, number 25, the answer is B.